Starting the live stream. That takes a few seconds. And once again, if you're a student, please make sure you've renamed yourself to your first name and then brackets your team name. Hey, I can hear myself on YouTube, so obviously we're ready. All right, we got the recording. Thank you.
All right.
All right, so today's presentation presenter will be Michael. Michael is a grade 12 student at WCI and a member of 2702. So he'll be going through the presentation. If there are any questions, post them in the chat. I will be monitoring that, and I'll also be monitoring hands if that works better for you. And yeah, take it away, Michael.
All right. Thank you, Eric. So, hello, everyone. Today, we're going to be using REPL for an introduction to programming in C++. So the first thing that we're going to do is head over to REPL.it. If you already have an account, you can create a new REPL in C++. And if you don't have an account, don't worry. Just head over to this link, which will be in the chat shortly, and you'll be able to write a program as a guest. You just won't be able to save it. And while we're going through C++, you can use REPL to follow along with what I'll be typing on screen. And don't worry, I'll be using REPL as well. And as Eric mentioned, if you have any questions, feel free to ask them or type them in the chat. So, I'll be now giving everyone about a minute or so to head over to REPL and open it up. So once you're there in REPL, you should see something like this. You'll see two sections. The section on the left is where you type code, and the section on the right is called the console. This is where you will be able to see the output of your program, such as any text you print. Now, if you look at the coding section on the left, you'll see some text that looks like this. Now, don't worry about the first line too much for now. That's just including the library IO stream, and it's just a library that simplifies the process for displaying text on the console, because we don't need to reinvent the wheel every time we want to display some text. Now, the next thing that you'll notice is that I have some extra gray text that starts with 2 slashes. Whenever you write 2 slashes, everything after that becomes a comment, and comments are useful for writing down what stuff is or what it does in your program. Now that we have that out of the way, let's begin dissecting what we're seeing here. Even though this is a basic program, there's a lot of new things to take in, so let's go one by one. And this is mostly the same as what you're seeing on REPL, just a little bit different and bigger, so it's easier to digest. So, the first line with actual code is int main with parentheses. This is called a function, and specifically, it's the main function. We'll be getting into functions later, but for now, all that you have to know is that any code that you put inside these curly brackets will be run once you execute the program. Next, we have a statement, which you can think of as a sentence, and it ends with a semicolon. So anytime you write a line of code that does something or performs an action, you need to end it with a semicolon. So now let's look at what this statement does. We have std : cout, the double opening angle brackets, and hello world in quotation marks. First, std cout, this is where you push text to for displaying on the console. The double opening angle brackets is called an operator, specifically the shift operator. We'll get into operators in just a bit, but here, all it's doing is pushing whatever's on the right over to the left. And finally, we have text in double quotation marks, which is called a string. Now on your REPL, you will have one more statement. This is called the return statement, and you'll learn that all non-void functions must return something. But here, all I'll tell you is that the main function doesn't need to have a return function. So let's review what we just went over. We have a string, which is just text, and it's getting pushed into cout by the operator. And cout will display it on the console. So on REPL, if you press run, which is this big green button at the top over here, that is exactly what should happen. Eventually. There we go. where you just printed hello world. Now, as a little exercise, let's do something in this coding section. Let's add those comments that I had before. So over here, I have this comment saying this is the main function and printing hello world. So let's do that. I'll make a new line by pressing enter. I'll type two double slashes, and you should follow along as well. And I'll just type, this is the main function. There we go. Now once you've typed that in, you can make a second comment. So I'm going to have two lines, just so it looks nice and neat and organized. And I'm going to add the comment, two forward slashes, and I'm going to say printing hello world. All right, now as an exercise for deleting text, let's delete this statement over here. So we can select all of it and press backspace or delete to delete it. Now, if we run the program, exactly the same thing should happen. And that's what we have. We've just printed hello world again. Now, you might be wondering what this purple text I have in my slide is all about, this \n. The backslash, whenever it's inside a string, denotes a special character, which is a character that doesn't have a letter, like pressing enter or tab. So let's try this character out. If you go to REPL, you'll notice that this orange cursor is on the same line as hello world. And that really isn't that pretty. So let's make it prettier by adding the new line character. So if we type \n and we press run, we'll notice that the orange cursor will be on a new line and separate from our output, which is nice and pretty. Now you might be wondering what happens if you just replace this \n with enter. Well, you can try that out. If you press enter and run, what you're going to get is an error because the double quotes in C++ only detect stuff on the same line. Now I'll just press Ctrl Z to undo that. And speaking of errors, a common error that you'll get is a syntax error, which is just like a grammar or spelling mistake. And generally, the compiler will tell you in the console where you made the mistake, what the error is, and sometimes how to fix it. So here, it's telling me that in main.cpp in line 9, I'm missing a semicolon. And that's exactly what's happening here. And if you have an account on REPL, you'll notice there will be a red squiggle in your code if you make a syntax error before you run, which you can hover your mouse over and it will tell you the same thing. And now you can go over to REPL and experience that firsthand. So if you open it up and delete the semicolon and press run, you'll get that syntax error. And you can do that for a second while I have to excuse myself for a minute. All right, I'm back. So you can see that you get the syntax error for the semicolon, and you can fix it by re-adding that semicolon. All right, so now let's talk about variables. Variables are things that hold information or data about something, a little like variables in math. To define one, you need to specify its type and its identifier, which you can think of as its name. Here, we can see that there are string, int, and float types, and all the variables here have a single letter for their name. And let's just quickly go over the types that we see here. A string type just holds a string, which if you remember from before, is just text, surrounded by double quotation marks. An int type variable will hold an integer, which is just a whole number, and a float holds a decimal number. Now, when you're naming a variable, you can't name them certain words. Those certain words are called keywords. Keywords are special words that generally denote a type and are highlighted. Here you can see a few examples, namely int and float. And because they're highlighted, you can't name variables these names. Now, another thing that you need to consider when you're naming and using variables our case is case. Variable names are case sensitive, so it matters which letters are uppercase and which letters are lowercase. So let's experience that firsthand. Let's go back to our REPL. All right, and let's just implement this code that we see here onto our REPL. So instead of having hello world directly pushed to cout, let's have it in a variable. And heck, let's even have two variables this time. So at the end, I'm going to press enter to create a new line. I'm going to type std string. And let's call it hello, all lowercase. Now we've just defined a variable. Let's initialize it with the value by saying equals to and double quotation marks. And in these double quotation marks, let's say hello. And as I said before, every statement needs to end in a semicolon. Now let's declare our second variable, which will also be a string. So std string, and I'm a bit lazy, so I'm just going to call it w for now. And it's going to be equal to and world, spelled correctly and with an exclamation mark. Now let's end that with a semicolon. So down over here in our cout, I'm just going to delete hello world, like that. And I'm going to add a new shift operator, which are the double opening angle brackets when you press shift comma on your keyboard. And I'm going to say hello. But just for fun, I'm going to say hello with a capital H just to see what happens. And shift in W. So once you have typed this code into your REPL and you press run, you will get an error, as you might have guessed, because the compiler will tell you that there's no such thing as the variable hello with a capital H, and it will suggest for you to use the variable hello with a lowercase h. And here you're experiencing case sensitivity, because it matters, as I said, which letters are uppercase and which letters are lowercase. All right, now let's fix the error and print it. And when we run the program, you're going to see that hello world is printed. It is, and it's printed as one word. This is because the shift operators, they don't actually print a space between the variables or the strings. We have to add that space ourselves. So if we go back to our variables, and after hello, and before the ending double quotation mark, we just add a space by pressing space. Now we run it, you'll see that hello world will be printed with two words. Hello world. All right. Now let's continue on to the numbers. As you can see from this slide, let's just initialize them and declare them exactly the same way. So int I, and let's initialize it with the value of 5. All right, and end it with a semicolon. Let's do the same thing. So float a is equal to 1.25, or 3 apparently. Now let's print those values. And you can print these values, as you can see, just in the same way as you print the variable with strings. Just std cout, and you push them using the shift operator into cout. So let's do that. std cout. Let's push I first. And let's push a new line character. So \n, just to make it look pretty, and semicolon. Let's do that one more time, but this time for variable a. \n. There we go. Now, once you have all of this typed out, you can now press run, and you can look at your program and see what it outputs. It's going to output the hello world, because you haven't deleted it, and it's going to output 5 and 1.25, the values of your variables. Now, you've probably already guessed that because this equal sign is also pink, just like these double opening angle brackets, it's also an operator. Now let's talk about that next. Operators perform operations based on the left and right expressions. The first operator here in this example is the equals operator, which assigns the right value to the left variable. So here it assigns 1 to I, so I is equal to 1. On the next line, you can see that we've declared a variable j, but on the next line, we initialize it. And the value that we initialize it to is an expression, and that expression is I plus 1. And this expression has an operator, the plus operator. And just like in math, plus adds two things. There's also the minus operator, which subtracts two expressions, two numbers from either side. However, multiplication and division aren't that cross or the division signal. Instead, in C++, they are the asterisk and the single forward slash. And the asterisk is what is the letter that you get when you press Shift 8. So, let's use this in a program. Let's try getting this and seeing what we can do with it. So, if we go back to REPL, we can try messing around with variables. So just to keep our program clean, let's just delete everything because we're moving on to a new topic. So once we got all of that out of the way, we now have int I, and it's set it to equal to 1. All right, now we can define the variable j like that. We don't have to initialize a value immediately on the next line. Let's give it a value. Let's give it a value of I plus 1. Now here, you can have any number. You can have 4, you can have whatever that number is, you can have 0. You can have anything there. And after you've chosen your favorite number to add to I, you can print it out. So std :: cout. And let's push into it j. And just to make everything look nice, let's have a new line character. So new line. There we go. Now we have this simple program, and once you've written all of this out with your number, you can press run and see what number you get. And you probably get the number you expect. So what the program is going to do is it's going to declare I with a value of 1, define j, and it's going to initialize j with I plus 1. And here I is 1, 1 plus 1 is 2, and j is equal to 2. Now you might be wondering, what's going to happen if we don't initialize j with a value? If we comment it out and then run it, what's going to happen? Is there going to be an error? Is it going to be 1? Is it going to be 0? Is the program going to crash? Is it going to run on forever? Well, you can press run and see what happens. And you'll notice that it's just 0. Now C++ is a little sneaky. When you define an integer and you don't set it a value, what it actually does behind the scenes is it actually initialize it with a value of 0, just so you don't accidentally cause some funky stuff. So that's variables and operators. And there are actually two other special operators that you should probably know about. Those are plus plus and minus minus. These increment and decrement the variable by 1. So here in this example, I initially has a value of 0. We increment it 1, 2, 3 times, so we're going to get a value of 3, and we print that. Then we use the decrement operator once, and we're going to get a value of 2. And that's exactly what the program prints in the console. So you can apply that in your REPL. Once you open that back up, and you uncomment that line if you hadn't done it before, you can play around. You can increment j once, you can decrement it, you can do it again, you can do it once more, and you can do it even more. So after you add some statements for incrementing or decrementing j, before the print of course, you can run the program and see what value you get. Now, ignoring that error because I put a colon instead of a semicolon, the value I get is -1. Because integers are not just whole numbers can also be negative. All right, so now you know enough to do some basic calculations with C++. Here, I have a program that would calculate the distance of a wheel with a radius of 10.5 would roll after 3 rotations. I calculate that value, and then I print it out with a string and that distance. And as an output, this is the value that I get. So, as an exercise, instead of using this exact program, what you're going to do is make a different one. I would suggest as an exercise to do any of these, such as creating or finding the area of a triangle, perimeter of a square, volume of a cone, area of a square, or surface area of a cube, any of those, or anything else that you want to do. If you don't remember a formula to some geometric object, you can just search it up online. Google has pretty much anything. So before I send you off to do that practice, do you have any questions? Or and does anybody have any questions?
So if you have any questions, just post them in the chat, or if you want to raise your hand, or if you just want to barge in and unmute yourselves, that works too. What we're going to do next, while you're thinking of questions, is we're going to break people out into breakout rooms, and then we'll practice one of these things. We'll pick maybe one of the simplest ones, say the area of a square, and we'll have people put that into the browser, into the code editor, and give that a try. So one thing you'll find with programming is it can make a ton of sense when you're looking at it on the screen, and then when you go to type it, it's kind of hard to figure out all those symbols. All right, question. How do you cut and paste so you don't have to type stdc out over and over again?
Now that's a good question, and it's just like any other program. The way to copy something, you just have to highlight it. So in this example, std:/C out, and you press Ctrl C. Or if you want to cut it, you can press Ctrl X. To paste it, you press Ctrl V, just like most text editing programs. And of course, you can press Ctrl Z and Ctrl Y to undo and redo.
I think you might also be able to right click it to be able to select copy and paste if you forget those shortcuts. Yeah, there you go. Cut, copy, paste are there. Perfect. Any other questions? There you go. Does it matter how you indent each line? Oh, that's a really good question.
So, C++ is not like Python where it matters how you indent your lines. Generally, or realistically, it really doesn't matter for the compiler how you indent your lines. Technically, you can have everything on one giant line just as long as you have your semicolons. However, that's really hard to read. So generally, you indent your lines by one tab for every nest that you go into. So, or every scope, I don't know the correct term, or immediately remember it. Here, this main function, it's in one scope, or the first one, so you just press tab once. And there we go. And since the function definition or declaration is in like the 0th, you have no tabs for it. That is generally the first, like not first, but convention that you follow in C++, just so you make everything readable for yourself.
Yeah, you'll learn more about the different scopes or whatever, but the easy rule of thumb is whenever you have a little curly brace like that, everything under it gets indented, and then when you close the curly brace, you outdent one. We'll teach you when you would use a curly brace in future sessions. And then another question, can I add a float variable to an int variable?
Well, that's a good question. We can try that out. And you can try that out by just trying it out. So if we have a float, let's just say 2 and whatever that is, 2.23. And we try to add that to j. And if we remove all of that and we press run, you can see whether or not it generates an error. Now, in this case, it didn't generate an error, and you can, in fact, add floats to ints. However, what you'll notice is that we're not getting 3.3 or 3.23. Instead, we're just getting 3. And that's because whenever you add in a float or anything with a decimal to an int, what the int does is it simply chops off the decimal. So if I have 9.3 in this case, it should still be 3. Yes, it is.
Yeah, you definitely have to be careful when mixing types. There are a set of rules. It is predictable when you learn what it does. And I think we're going to be talking about what's called casting, so making one type a different type kind of more on purpose rather than just hoping it works. And we'll cover that in the later workshop. All right, we've got the, how does the less than, so the shift operator, work? Like when should I add them? So what exactly is their purpose, or when should they be added?
So answering what exactly this operator does is a bit more of an advanced question, because technically this would, well, the technical answer is that this shifts over the bit in a binary number. But that's technical, it's boring, and realistically, what you are going to use it for is just pushing stuff into cout. So that's the only time when you're doing basic C++, you're ever going to encounter this. Only when you need to push something to C++, like a variable or a string, that's when you're going to add it. And you have to have one shift operator per um, variable or argument for this. So if I try to have two j's, it's going to complain, saying that it expected an operator or something else between these two j's. So if I wanted to press or print j twice, I would have to have two shift operators in between them. And here it's printing 33 because I don't have a space. So basically, for everything that you want to print onto the screen, you need to add a shift operator, and that's it.
Yep, exactly. Any other questions? All right, so what we'll attempt to do now is send people to breakout rooms. So at this point, we'll probably stop the recording and the streaming because the breakout rooms aren't visible from the recording or the stream. So if you're on YouTube and you really want to participate in a breakout room, then hop onto the Zoom link and you can join us. And if you need to leave at this point, that's okay too. Hopefully we'll have enough senior students and mentors spread out through the room so that we can help each other. If you really get stuck, maybe we can share some screens too, so we can really look at what your code is, because it's hard to describe without seeing sometimes. This is new to us, so we will see how it goes. If you have a problem, you can send me a message, and I can move your rooms if you want to be with a friend, although hopefully we won't spend 10 minutes trying to jump rooms. And yeah, if there's any problems, just text me or come back to the main room and talk to me. One of us, either Daniel or myself, should be in the main room, although we may also jump in the breakout rooms to check how things are going. All right, so first I will, I think I'll first assign automatically, because otherwise hand picking 34 people will be hard. Let's make 5 breakout rooms. That'll be 6 to 7 participants per room. So hopefully that gives enough. Let's see what 6 is 5 to 7. Let's make 6 breakout rooms. So 5 to 6 participants per room. I will, if you're a mentor and you find yourselves in 3 or 4 mentors in a room, let's have things shifted around. So you can come back to the main room or just message me and I can shift people around. So we'll see how this goes. It's a bit new, and hopefully it'll work. All right, so I'll create the rooms. We've got people there. So Daniel, I can't not assign you, so just exit the breakout room once you're in there. Come back to the main one. If you hit leave meeting, you can come back to the main room.
Okay.
I got some mentors around. Let me move. I'm just moving the obvious ones that have no mentors. Maybe to 4 there. Okay, and then maybe another one to room 2. Room 2. All right, that should be decent. So I'll open all the rooms, and then there will be, I can send a message at some point when it's time to close things up or wrap things up. So opening the rooms. All right, and for those of you who joined us on YouTube, we'll say good night for now, and we'll talk to you later.